English code like I said.
I mean,
Alright, work this problem right up here on the screen. It will be up here. It will be up on the screen shortly.
Is that our quiz?
No.
Yeah, Corbin. Corbin, you can't have it be the same thing, so you're just gonna smack your desk, right? Dude. Hey, that was one day.
We do have a quick little 10-question quiz here.
Quick.
10 questions. I'm gonna miss 2 and that'll be give you about 10 minutes probably.
You have to make it.
Nope.
10 minutes on it.
Or is it just like what we did on the multiplication
time test?
Yeah.
It's very similar. It's very similar. Do this problem first though.
Oh, wait, the number.
A equals per.
Who am I missing, Jacob?
What?
Okay, so when you started there?
20 years.
Oh, gosh, 1,000.
Okay, well, this is 1,000
But I could have put it.
Okay, but then what is the balance? 0?
Oh, wait, I'm rude.
How do you know?
Hey, it's like 11. It's like, I know. I think.
Oh. Okay, yeah, you're good. So A equals 2,000.
Oh.
So you want to double it, so that's only we can match the amounts would be 4,000.
Alright?
What? What? I don't know, I didn't hear you. See if I did this right. Alright, 9,000, you get 2. 6.75.
Actually, now I got one.
Yeah, no, I got it.
I don't understand.
Carly, do you get 10 points? I was confused that.
Okay, how'd you set it up? Or like, what was your last step?
I did the like actual log on both sides to get rid of the E, and then I just did .0675 T.
0.0675. That's right.
10.27.
Alright, 10.27 years. 10.27 years.
Yep. 1 second, I think I got this.
I got it.
Do we have to have this memorized?
Well, it's a return. You came up telling us.
Huh? Excuse me, coach.
Alright. Okay, so yesterday's lesson was about solving these exponential and log equations. When you have an x inside of a log, or you have an x or the variable inside of the exponent in an exponential, how do we solve those? Now, there's actually two ways, and I think Mrs. Linda talked about both ways that you can do it. We're going to talk about that some more today. So this is an example of first set, kind of a story problem, but first setting it up. So I heard some discussion, good discussion here about the first thing. So $1,000, that's the A, or the P. I'm sorry, that initial amount. Okay, that initial amount at time 0. Now, it's important that that's at time 0, and the reason the initial amount P has to be at time 0 is if you put a 0 in for T, this is e to the 0, which is 1, and then P is equal to the amount that you have. And so at time 0, the amount A that you have is P. So your beginning amount always goes in for P. Okay? So the 1,000 goes there, and then you had to make up the 2,000. It said how long will it take to double your investment. So that means the amount A turns into 2,000. Okay? And so everything plugged in then looks like that. Now, before, one of the things that hopefully she talked about yesterday, but is important in solving an exponential equation, solving when the variable is up here in the power, is you have to isolate the exponential on one side by itself. Same thing with the log, if you're trying to, especially if you're using the method where you convert forms, which we're going to do here in a minute. Okay? And so you want to divide the 1,000 over to the other side. So you get the exponential here by itself. Okay, very important. You cannot take this number here times this base. This doesn't work. Now you don't feel like doing that when it's an E, because E feels more like a letter. Well, it is a letter, but it feels more like a variable than it does a number. But if you have like 2 times 3 to the x, you cannot make that 6 to the x. You cannot take that 2 times that 3. Okay, that doesn't work. So it'd be the same scenario. So if you had something like this and you were solving this problem, you would need to divide that 2 over there. Okay, you cannot put this 2 with this 3 ever when we're doing exponential type equations. Okay, anyway, divide the 1,000 over, you get this. Now, the direction you go from here, there's 2 choices. Okay, let's go down the blue path here. The blue path would be converted into log form. So one of the first things we learned here with exponentials and so forth is, let me see, am I recording? Yes, okay. Is converting something like this into its log form. So here's the base, so that'd be log base E, which of course we know is ln, but sometimes we write it log first. So log base E of 2, remember, E raised to this equals this, right? E raised to this equals this. So log base E of 2 equals that. What that does for you is it gets the exponent, the letter, out of the exponent. And now we can use our regular algebra solving techniques. So log base E is just ln 2, and now we just divide both sides by 0.0675. You divide that out, you get 10.27. So one way to solve an exponential equation or a log equation is to convert forms. Convert forms. Okay? Some people like that method best. I don't really care one way or the other. They're both fun. Okay? The red route. So once you get to here, right, you can go that route, convert forms, or you can do this, which is to take the log of both sides. Now, you can do any log you want. And we learned the other day about the change of base formula where we can convert, see if you remember this real quick. If I have log 4, 8, right, how can I type that into my calculator? Log 8 divided by log 4, ln 8 divided by ln 4. Now, I have a preference for ln. I'm always going to use ln. Okay, and part of that comes from teaching calculus and just knowing that shows up a lot more often. Okay, so when I say log, I'm going to do ln. Okay, so you can do the log of both sides. Now, what that does for you, you've got this letter up in the power, but when you do the ln of both sides, what was the log property we talked about on Tuesday? When you have the log of a power, what can you do with this power up here? Remember that? Log, I don't know, base, it doesn't matter, any log. If you have b raised to the c power. What can we do with that c? Bring it down in front. Anytime we have a log and there's an exponent inside of that log, we can bring that exponent down in front. So what we can do here is we can bring this down in front. Now I kind of skipped a step in here. You can bring this down and you have 0.0675t times ln e. But what's ln e? ln e is 1. ln e is 1, because remember, this is base e. So that's e to the what makes e? E to the first. ln e is 1. Now, what if this wouldn't have been an e base? Doesn't matter. I mean, it worked out nice, but we would just divide. We would just divide it over. If this would have been, say, 2 here, or 4, let's say this had been 4 raised to that, we'd have brought the 0.0675t down, we'd have ln 4 here, then we'd have just divided the ln 4 over here. We'd have ln 2 divided by ln 4, and then we would divide the 0.0675, okay? And so, again, you come up with the same answer. So that's why you can do ln 4. Let me just show you another quick example of that. So if I had 7 equals 5 to the x, just to pick real easy. Now, some people would say, oh, since the 5 is your base, maybe you should do log 5 to both sides. Okay, we could do that. Let's do log 5 to both sides. Okay, and so you get this. So I just did log 5 on both sides, right? Now, over here, that's nothing. I can't do anything with that just yet. What's going to happen on this side? What did we say we can do with that x? Now, actually, to be honest, we talked about one like this. You should just be able to look at this, and that's what? That's just x, right? Because it's 5 raised to what gives you 5 to the x? Oh, 5 raised to x. It's like they cancel each other out. Base 5 here, they cancel each other out. But let's do it this way. Let's bring the x down and log 5, base 5. Well, what's that? That's 1, right? This is the little 10-question quiz we're talking about doing, things like that. You got something like that. What's log 5, base 5? Oh, it's 1, right? Just no calculator, just write it down. Okay, so that's 1. Okay, so we don't need it. Now we got log 7, base 5. Well, how are you going to take that in your calculator? We just talked about it.
Log 7 divided by
Log 7. Now I prefer ln, so I'm going to do ln. So I'm just going to do that, and there's my answer, right? Well, so the argument could be made that if you've got a base 5 there, do log 5 on both sides. Well, I just do the ln. I don't care what the base is. I do the ln every time. So let's do the ln on both sides. See what we get. ln. Okay. Well, what can we do right here? Bring down the x. So we got x ln 5, right, equals ln 7. Now what? Divide both sides by ln 5. Look what you get. See, and then you just don't even mess with these other bases. Look, same thing. ln 7 divided by ln 7 divided by ln 5. You don't have to mess with it. Okay, so I don't care what the base is. If you've got an exponential, one of the ways you can do it is just to do the ln of both sides. Bring that power down, and then you get the power by itself, and you got it. Okay? Now, the other way that Ms. Leonard talked about it, what we could do with that is we could just convert forms, right? What would this be converted? That'd be log base 5 of 7 equals x, right? Instead of doing the log of both sides, that's one of the methods. Do the log of both sides. I do ln for my log, but do log of both sides. That's one method. The other method is just convert forms. Well, heck, you're done. You're basically done here, right? How do we do this? We do log 7 divided by log 5. I would do ln. Same answer, right? I mean, it doesn't matter. Either one. I don't know that one's a little quicker than the other. Depends on the problem, maybe one less step, whatever. It truly, they truly give you the same thing. Okay? So, I guess if I had a preference, if I have to pick one, I do the log of both sides. Just what that in my mind, what that takes away is, well, I think Seth said it. When I said right here, I said, okay, this would be log 5 of what? And what you said? You said x instead of 7. So the danger to me of converting forms is you just put something in the wrong place. Put something in the wrong place, then you've messed it up. by doing the log of both sides, I really don't think you can mess it up. Do the log of both sides, you bring the power down, you divide, and so I guess that's probably why that would be my preference if I was you. Okay? But it's totally up to you. All right. So let's do this before we get into the homework questions, and we can go through some of those. Let's do this quick little quiz. Let's review a few things. All I'm talking about here is, okay, just doing some basic log stuff. So let's look at a few. This is all the quiz is right here. Okay, so stuff like this. Okay, so no calculator. Okay, so what is that? 4, right? 3 raised to what? Now, if you want to put a little box here and then convert, and so 3 raised to what is 81? Okay, 4. Okay, so the answer would be 4. What?
-3.
Oh, you were giving the answer. Okay, yeah, like you need to raise your hand. All right, right? Because this is 2 to the -3. 1/8 is 2 to the -3. So again, you're saying 2 raised to what makes 1/8? 2 raised to the -3. Okay, that's the kind of stuff I'm talking about doing. 10 quick little questions. Not going to be worth a ton of points or anything. Okay. Unless everybody does really good, maybe I should make it worth a ton.
Can't use our calculator?
No calculator. No.
Okay.
No.
Mental math.
No.
Okay, so let's just say everybody gets 100.
What?
100
Use your
points.
fingers.
Guys, it's okay, we still have Morse code.
How about this one? Not possible. Undefined. I'm not going to give you. But I should. It's easy. You cannot have a negative inside of the log, right? That'd be not possible. I'm not going to give you that. All right. All right, so do this real quick. When you get done, you can start on the IXLs a little bit. We're going to go over homework, and then we're going to have IXL work time today. Okay?
Get my nails.
If you miss 2, it's a B, don't worry.
Really?
Remember, if there's no base on the log, it's base 10. If there's no ln, is always base e. All right, 111, read it to me. Log 8x.
Minus log of 1 plus square root of x equals 2.
Okay, so just to review, hopefully some strategies you guys talked about here, and also there are some strategies at the bottom of page something 244. There's a box that has 3 sentences. Rewrite the original equation in a form that allows the use of the one-to-one property. So like if you have e to the 3x equals e to the 8th, then 3x equals 8, right? And then you can just get it from there. Or log, 2 logs that are equal to each other, same base, then what's in the log would be equal to each other. So that's a one-to-one property. Rewrite an exponential equation in log form and apply the inverse property of log functions. In other words, write it in log form, and then you can just solve it from there. Maybe the change of base or something like that. So that's where we said change the forms. And then rewrite an exponent or a log equation in exponential form and do the same thing. So those 2 strategies are basically change the forms. Now we also said if you have an exponential, you can do the log of both sides, and that's a good strategy too. Okay, so first of all, and we apply these properties. So we have a property with minus. And what did minus mean? Division. So we want to turn this into a log of 8x over 1 plus square root of x equals 2. Okay? So now, and do I have the right log? There wasn't another base on it, right? It's just log. Yeah, so base 10. Basically base 10. Okay, what do we want to do from here? Change it into an exponential, right? Whenever we have, so we already talked about having an exponential where you have an x up in the power, do the log of both sides, or turn it into a log. Here you have a log, turn it into an exponential, because we're trying to get this x here somehow so we can solve for it. So what we want to do, there's a 10 right here, so 10 raised to the second, which would be 100, is equal to this. So you get 8x over 1 plus square root of x. Okay, now it would just be a matter of trying to get the x by itself. Solve the x and go from there. Okay? So what can we do? We can multiply this side, this over this side. That'd be 100 plus 100 square root of x equals 8x, like that. Right? We could, I don't like that very well though. I wonder if we should have left that. We get the x's over here, so we get 100 equals 8x minus 100 square root of x. This is where it might have been a good idea to look at this one ahead of time.
Sorry, how did you get the 100 equals 8x over?
This right here?
Yeah.
So that's just changing forms. So this raised to this equals that. So 10 to the second is 100. Now it's just algebra. Harder algebra than I'm going to make you do.
They have like 725 plus 125 square root of 33 over 8.
Right.
For 111.
Yeah. Well, yeah. Well, what this is, again, I would want you, I would, for sure, we want to get down to here. It's not going to be an algebra test that we do, okay? That doesn't mean, I say this in calculus class all the time, we oftentimes do problems harder than maybe what will be on the test. We want to do them, we want to know about them. Doesn't mean they will necessarily be on the test. So everything with log properties is down to here. Now we get into algebra, okay? And what this is, if you look at this, let me go to the next page here. So this would be 8x minus 100 square root of x minus 100. So if you see what I had here, I'm going to minus this 100 over to this side, and then equals 0. Well, that is actually a quadratic in disguise. Okay? For example, if I gave you this problem here, we would all recognize this one. Let me give you a real easy one here. 5x plus 6, this is a quadratic, right? And this would factor into what? X plus 3, x plus 2, right? Because x times x is x squared, 3x, 2x is 5x, and then this. Okay. And hopefully, you might also recognize this as a quadratic. Right? This would be x squared plus 2, or 3, and x squared plus 2 equals 0, correct? Okay, now it would turn out that neither one of these will ever equal 0 because x squared can't equal negative 3, x squared can't equal negative 2, so this would actually have no solution. Well, this one, let me add one more to the mix then. X plus 5 square root of x plus 6 is also a quadratic. Okay, this would be, well, you tell me, what would go in this one? Square root of x plus 3 and square root of x plus 2. Square root of x times square root of x is x. 2 square root of x, 3 square root of x is 5 square root of x. 2 times 3, okay? So, that's what I mean. This is way more algebra than I'm going to make you do. But we can simplify this by dividing everything here by a 4, so we can have 2x minus 25 square root of x minus 25 equals 0. And you can actually do quadratic formula on it if it doesn't factor, or make sure this one actually does factor. It doesn't. So, yeah. So way, more into the weeds. But what you would do here is you'd say, well, square root of x would equal, and then you do negative b plus or minus, and that's where they got all their blah, blah, blah. Don't worry about that. Okay? It's just algebra. It's just some algebra. Okay? But as long as we can get to that part right there, right, then we're good. Which is okay. I mean, it's worth looking at. It's worth doing. That's why it was assigned. But won't have that hard of algebra to do on the test. Okay, what else? What else?
59.
59.
No. 63.
63. Okay, read that to me. 500 over
100 minus e x over 2
Okay, I would write that as 1/2 x, but that's okay. X over 2
equals 20.
equals 20. Okay, so what about this one? Okay, first step. What do you think? Multiply this over to there. I would try, normally, again, if you're going to change forms, if you have an exponential, it's good to try to isolate that. Okay, try to isolate that exponential by itself or the log by itself so that you can maybe change forms or maybe do the log of both sides. Okay, so again, initially here there's some algebra. So if we multiply this over to that side, then that's going to be 500 equals, now we got to distribute that, so it's going to be 20 times 100, which would be 2,000, and then 20 times this, so that would be e to the 1/2 x. So multiply this over to the other side and distribute. Then what? Subtract 2,000. So negative 1,500 equals negative 20 e to the 1/2 x. Okay? Then what? Divide by negative 20, which you get rid of a 0, and then 150 divided by 2 is 75, and it would turn positive, and we would have e to the 1/2 x. Okay, now at this point, this is where you have your choice, right? You can turn it into a log, or you can just do the log of both sides. I'm going to do the log of both sides, so ln 75 equals ln e to the 1/2 x. We get good enough at those, you can just see what's going to happen when I do the log of this side. What's ln e to the 1/2 x? 1/2 x, right? You bring the 1/2 x down in front, then that's ln e, or you just say, okay, that's a base e, that's a base e, they cancel each other out, stuff we talked about earlier in the week. but that's a 1 right there. So we get 1/2 x equals ln 75 times by 2, you get 2 ln 75, and just leave it. To be honest, just leave it. I mean, in calculus, we often have, we have in the AP test and in a lot of our tests, we have a calculator part and a no calculator part. A lot of times the problem like this is in the no calculator part, okay? Well, the calculators we use in calculus actually would solve this. We could just tell it to solve that, and it'll just solve, right? So sometimes we want to do that, but other times we want to show we can solve it. So in the no calculator part, so you just stop right there at 2 ln 75. On our test, even though we're doing a calculator, really the calculator doesn't help you a whole lot unless you need help subtracting or dividing, okay, which is fine. But the calculator doesn't really help you a whole lot other than those things until the very end. There's no need to type that in your calculator and give me a decimal. I'm perfectly fine with 2 ln 75, just leave it. Matter of fact, it's easier to grade than the decimal, right? And your rounding and stuff like that. Okay, what else? Anybody else got one?
101.
101. ln x, read that to me, plus,
ln x minus 2 equals 1.
okay? So again, you have 2 logs added together. What can you do to put those together? To condense them. Multiplication. So this becomes ln of, and now we can take x, so it'd be x squared minus 2x equals 1, like that, right? So and that goes back to that rule, ln of AB is equal to ln A plus ln B. Okay, so you can put it back together, you can condense it. So ln A plus ln B is ln AB. Okay, so we put that together. Now we can just make this into, so e to the first, which would be e, is equal to x squared minus 2x. So subtract that over, we get x squared minus 2x minus e. And then that's more quadratic stuff.
Okay.
Yeah, I mean, I'm guessing the answer probably has some quadratic.
It's like 1 plus.
Yeah, I mean,
1 minus e.
Yeah, this is just ABC. I mean, quadratic formula. We'll talk more. We're going to review more Monday. We probably won't do tests on this stuff till Wednesday, probably Wednesday. So we can have time to talk a little more about this. I mean, I got a couple worksheets with some stuff, and we want to get fairly proficient at this. But the quadratic formula would be 2 plus or minus square root b squared is 4 minus 4 times 1 times c, so that'd be 4e. That'd be negative, turn into that. All over. What'd you say it said on in the back?
Oh, it was like. 1 plus square root of 1 plus.
Yeah. So you see what I mean, right? This square root right here, we could take out a 4. So inside that square root, you could have 4 times 1 plus e, like that. And then you could split that into square root of 4 times square root of 1 plus e. Square root of 4 is 2. So this right here becomes 2 square root of 1 plus e. That's what this would become. Okay? And now what can you do on this top? You can take out a 2. You get 1 plus or minus the square root of 1 plus e. All over 2. Those 2's cancel. And that's why their answer was 1 plus or minus the square root of 1 plus e. Okay? But again, once we get to this part, it just, using your knowledge and things you did back then. Okay? All right. Well, let's stop there. If you got, we'll save a few more for next Monday, and some of you haven't had a chance to work a lot of those. But we've hit on a few of the more difficult ones, but using those properties, put these things together, and then go from there. Okay? So you can work on IXLs a little more. That's the only homework for Monday then, is catch up on the book assignment if you're gone, and catch up on IXL. Okay?